Banks work on relatively tight time frames. When we collect checks for our customers, we're not just talking about pieces of paper, we're talking about our customers' assets, and we want to process them as quickly as we can through the check collection system. As a major bank in a large metropolitan center, we service many corporate accounts, and we wish to process as many of their checks as we possibly can. And many of us feel that the check is going to be around for quite a while. Banking is a paper-intensive and a people-intensive business. In all of our processes, we try to reduce the labor content of our products so that we can protect our unit costs from the impacts that inflation has on a labor-intensive process. Throughout the banking system, in order to process checks effectively, the first operation has to be the encoding of the dollar amount on the check in the lower right-hand corner of the document in magnetic ink. That's a manual process. In our bank, a number of the checks that come to us from our depositors are already pre-encoded by the depositing bank or by a major depositing corporation. But for many of our checks, we have to do that labor-intensive process here at the First National Bank of Chicago. When IBM first approached us with the idea of participating with them in a joint effort on the 3895 deposit processing system, we were pleased to participate in that effort because it appeared to give us a chance to reduce the labor-intensive nature of the check encoding process. With the 3895, we'll be able to pass our checks through the device, and it will literally search for the dollar amount on the check and read it optically. As it does that, it will compare what it reads with the amount written on the deposit ticket or on the adding machine tape supplied to us by the customer, and after making a number of comparisons, it will then encode the dollar amount on the check in the proper area, and we will have completely bypassed manual encoding operation. We've been working with IBM in this joint project for a little bit more than a year, and we've had the device here for a little bit more than 6 months. The people who are working closely with the 3895 are very excited about it, and that's very important to me because in the final analysis, it's those people that really will make this system work.
What the 3895 does for us is it allows us to get a total system, a total capture system. And this system certainly is not just encoding of the check. It's capturing the checks that they are going through the process. It's taking all of the other checks that were not in the process, re-entering it back into it, and coming up with 100% capture of every item. The enthusiasm that I might show is probably shared by the people that are actually doing the physical work.
I was supervisor of the proof area, the encoding machine operators. And when IBM came into the bank and suggested it, and I was one of the people that was chosen to come in here, and I've been fortunate enough to learn the whole phase of the operation. When I was out on the floor, all the documents had to be hand-fed into the machines and hand-entered by each operator, and we processed, quite a bit of work. Standard right now is 1,150 per hour, and in here some of our operators are already up to 1,800 and 1,900 items per hour.
The actual system starts off with a preparation of documents, which is done in a little room that we use a machine called a 3896. This machine will give us on a tape copy and break it down into a machinable type document, which we introduce into our system. The machine now has the ability through its optical scanner to compare what it sees on the check and compare it against the incoming tape. If it agrees with what it sees, it will then encode on the bottom line of the check. Once that encoding is done, then the check is at a point where we can do something with it. The machine itself will read all of the items that is possible to read. It'll store the good items that it has read and actually encoded upon into a pocket. The other items it cannot read will be stored into another pocket. We now bring the checks into a station where we're going to do our key entry. Now, as this terminal is picking these up, it's also storing it within the system. And these amounts that she's picking up, that when the checks are re-entered into the system, will be compared against the actual physical item on the check against the data that she keyed in. This system will enable us to capture the rest of the 50% or whatever reject amounts there were.
During the second pass run, all the unencoded items will now be read and matched and inscribed by information that was entered into the system by the key entry operator,
which will enable us to make sure that every entry that came in is going out the same way as it was adjusted. We again are actually bypassing several operations in this process. We're bypassing what we knew as the old encoding. We're bypassing what we knew as an entry run into our computer system, and now we're at a point where the document has been captured and it's ready to be sent out of our bank. When IBM brought the 3895 into our shop, why, that was the first time we had seen it. And again, the reaction that I experienced was, it's just another sorter. But not like the other sorters. I mean, when you start looking at the process that this particular sorter can perform, it tells us that it can read optically, it can read magnetically, we can encode on the bottom line.
Well, I was fascinated because I just didn't think there would be a machine that can optically scan, you know, hand-printed amounts from checks, because some of those documents that were coming back, you couldn't even tell what they were. It was, you know, pretty difficult to read what the amount was. Well, the key entry operator obviously read the check, read the dollar amount from the check, and keyed it in. And then when it went through second pass, this information told it was now okay to be inscribed and gave it the correct amount.
I think it's very important to look at the entire system, not just the encoding of the checks and the rejects and the readability amount. I think the important thing is to look at it and say, okay, the machine does a certain amount of this process. There are other stations within the process that picks up and does the rest of the work. So when you finally finish the entire process, you've got a 100% capture system, which from beginning to end, which costs you less to operate than the present system that we've got now.
With the present process, additional check volume means more people, more machines, and more space. With the 3895, we've got some room to grow.